right, so today, again, we are here for an introduction to the Desmos online calculators and accessibility. We'll start with just a brief introduction from FIMC-VI from us, and then we will hand the floor over to Steve and Marielle from Desmos, and we'll adjourn at 3 o'clock and move on with our afternoon. Our objectives for today are that you will be learning about various online calculators available through the Desmos Studio for students with visual impairments. You will figure out what accessibility options are available for these online calculators, including how they function with screen readers and braille displays. And you'll learn where to find resources for Desmos online calculators. Okay, for now, just take note that the opening code for today's webinar is online. Okay, online. All right, so just brief information about Florida Instructional Materials Center. I know many of you are very familiar with us, but we are a statewide resource center for K-12 students who have vision impairments and are enrolled in a public, private, or homeschool learning environment. FIMC-VI is located in Hillsborough County Public School District, and we are an IDEA-funded state project maintained by the Florida Department of Education, Bureau of Exceptional Student Education Services. Our vision and mission is to promote the success of all of Florida's students with visual impairments by providing free and high quality accessible instructional materials in a timely manner, and providing teachers, administrators, family members, agency personnel, and anyone who wants to join in our learning processes the opportunities for training and professional learning. And in order to do this, we offer a wide range of free services to all of our stakeholders, including all of the many things that you'll see listed here, which include materials, accessible materials, professional learning opportunities, a loan library, many student and family events. Speaking of which, the Cane Quest is coming very soon. I hope that you all are registered, that your students are ready to join us in Tampa. Registration is still open and we need you. Please come and join us at Cane Quest. Bring your students and have them show all their skills. That's coming up November 12th. So come out and join us. For the rest of our services, I would invite you to visit our website, come and see our upcoming events, check out some of our new professional learning communities that we have for new VI professionals, and mentor supports that we have available for new VI professionals in the field. All right, so as we get going into this very math specific content and topic today of calculators, I thought it might be important for us to focus our minds on what is the role of the teacher of students with visual impairments, and what do we do for math access? Because this is certainly not a one-person job to ensure access for our students. Ideally, it's a collaboration between the teacher of students with visual impairments, the classroom teacher, and I beg to say, the parents. It's certainly a shared ownership, okay? And part of what we're doing is pre-teaching concepts and skills that are related to math. We might be pre-teaching Braille symbols. We're certainly going to talk about pre-teaching calculator skills. We could be pushing in and modeling some of these skills and concepts for other people who would then carry those out throughout the rest of the day. And we would be providing resources for making accessible classwork and homework. And perhaps we're doing that, again, in a collaboration with the classroom teacher. Checking in with them, having perhaps a shared planning time to really increase that communication with classroom teachers and identify what's happening, talk about adaptations, maybe peek through an APH catalog and see what they might need for the upcoming month, quarter, semester, school year, have things ordered and show them how they could be helpful in making education truly accessible to their students. Some of our teachers might have syllabi that we can look at and really plan to make learning accessible. Okay, so how does this apply to calculators specifically? All right, as a TVI, we will be responsible for pre-teaching and teaching calculator concepts. Did you know, though, that the abacus is sort of a great way to teach some of these foundational calculating concepts? And you can start that very, very young. All right, but when we're teaching the calculator, we're going to be teaching orientation to the keys. How do we turn it on and off? Where do we hold the calculator? Where are the numbers? What are operations and how do I find those buttons? Where's the enter key? We'll work alongside the classroom teacher to continue this instruction from early on until more advanced features are used. And really talk about orientation and availability of making these things accessible, which is really what we're going to talk about today. And we want to really think about how the math teacher can be involved as well. And so while the math teacher is teaching concepts, maybe we talked about pushing in, maybe we're pushing in and we're teaching how to use the calculator. And then there's that shared opportunity possibly to co-teach. Maybe it's during small groups, maybe it's after school. But we want our classroom teachers to feel just as confident as we are and the students are in the skills that they're learning in math, so that they can share that ownership, okay? Because it's again, not just a one-person job to ensure educational success of our students. So when do we start bringing calculators into the mix? And this is a list. You'll see some examples of when calculators can be used and introduced. And usually we can see here that calculators are introduced by the end of 3rd grade, but math instruction and concepts begin so much earlier and well before what this chart dates. This is a timeline that is outlined and based on when calculators are used on standardized assessments. But this can be largely altered based on individual student needs, classroom instruction, and district needs. So if we look at this chart, we see we know math concepts are started very, very young, right? Preschool, we're talking about one-to-one correspondence and counting. And so we can be pre-teaching we are pre-teaching the calculator in preschool, okay? And when we introduce the abacus in really early grades like kindergarten, and but the expectation of calculator knowledge begins really in 3rd grade. And that's basic 4-function calculators, 3rd to 6th grade, not just in math, but we want to also think about general science. As we get into 7th and 9th grade, maybe reaching further into scientific calculators, general science, algebra 1, chemistry, right? We're getting into much more complex subject areas. 9th to 12th grade, we're reaching into graphing calculators with algebra 2, geometry, statistics, maybe some of our students taking pre-calculus. So much higher levels of math and different types of calculator access. So just food for thought as to what our role is with calculators in math and when to begin this type of instruction. And now I'll go ahead. Now I'll hand things over to Steve and Marielle, and they will talk with us about this wonderful calculator that is available to us now online and accessible for our students. So Steve, Marielle, I'll hand this over to you.
Okay, thank you, Tiffany, and good afternoon, everyone. My name is Steve Clower. I am the accessibility specialist at Desmos Studio, PBC. Before I talk about who I am, what I do, I want to give my colleague here, Marielle Gardner, a chance to introduce herself. So Marielle, please.
Awesome. Hi, everyone. My name is Marielle. I've been with Desmos Studio as a user support associate for a little over a year now. So I work on the support team and help respond to any questions people write in about the calculators, about what they're working on, and we get people writing in all the way from students to professionals to people in industry. So it's a really fun, exciting job where I get to hear from a lot of people in the community. And I also help work on a lot of our documentation for new features. My job here is kind of ever evolving, which is always fun. So yeah, I'm joining you here from Kansas City, Missouri, and I'll be helping monitor the chat. So as Tiffany said, if you have any questions, please don't hesitate to drop them in. I'll be taking a look and can answer them in the chat, or we'll bring them up to Steve as needed. Anything else, Steve?
No, I think that's good.
Awesome. I'll go ahead and drop the agenda then, and I'll pass it over to you.
All right. Thank you, Marielle. All right, so back over to me. I suppose I should say where I am as well. I'm located in Fort Wayne, Indiana, which is the northeast corner of the state. So we border Northwest Ohio and Southwest Lower Michigan. I always have to mention that because nobody knows where this city is. Anyhow, I've been at Desmos Studio for coming up on 9 years in just a couple months here. And for a long time, my role here was as a software engineer exclusively, at least officially. But as Marielle alluded to, jobs here at Desmos Studio, we're a pretty small company. So many of us wear multiple hats. I did for almost my entire tenure here. And so I'm now officially on the product team. I still do some engineering, but also a lot of professional development outreach like we're doing today, user support, documentation, and all that other kind of stuff. If it's accessibility or internationalization related, it falls under my responsibility. So we're all pretty busy here at Desmos Studio. And the reason I'm at Studio in the first place was because my own accessibility story with math was very negative going through school, especially throughout high school and into college. And somehow I wound up sending a job application to Desmos Incorporated several years back because I found their online graphing calculator, which wasn't accessible, but it was built on a technology that could have been, unlike everything else that was out at the time. So they gave me a shot, and as I said, the rest is history. So I'm glad to be on the other side, helping build the tools that today's students can now take advantage of, and hopefully not go through the frustrations that I did. Well, I say lots of blind students, including me, a couple decades back. All right, so what are we here to do? And maybe more importantly, what are we here not to do? So the purpose of the presentation today is to give you an overview of the accessibility supports that we have inside of the Desmos tools, which includes our four-function scientific and graphing calculator, as well as the geometry tool and 3D construction tool, neither of which we will be going into today, but they do exist, so I should at least mention them. Oh, and our matrix calculator. That's always a forgotten lost child. But so we're here to demonstrate those features. I'm not here assuming any kind of math literacy. So we're not going to go into crazy math problems and have you try to solve them or explain what, some things mean on a graph. We're going to do some math to demonstrate the features, but I'll try to keep this as, plain as possible to get the ideas across and not try to show off math stuff, unless you want us to. And if you have any questions, I'm absolutely okay with either someone interrupting from the chat or whatever. We're doing this for you, so whatever's most helpful, we're happy to just roll with that. So that said, do we have anything in the chat so far before we begin?
Not yet.
Okay. All right, so before we start, let me give a brief overview of Desmos itself. Back in 2011, the original company called Desmos Incorporated was founded by our CEO, Eli Luberoff. And over that time till 2022, we developed quite a few products, including our graphing calculator. That was actually our very first product. And we created a scientific calculator and four-function calculator a few years after that. And once that was more or less set, we turned our attention to creating an interactive curriculum called Desmos Classroom, which I suspect some of you may have seen. in the past. And that technology ultimately wound up getting acquired by Amplify Education. So that's why I mentioned Desmos Inc. versus Desmos Studio, because when that happened, Desmos Inc. was dissolved, and the majority of our staff wound up moving over to Amplify to continue work on the Desmos Classroom product, which has really taken off now. It's amazing what over 1,000 employees can do versus about maybe the 60 that we had at the time. Those of us who did not go to Amplify spun off a new company called Desmos Studio, of which Mario and I are a part, and Eli Luberoff is still our CEO, by the way. And our responsibility is now exclusively the tools. So all of the calculators, geometry, and 3D construction tool, that's what we do full time. And last couple of years, we've been able to make some pretty big strides, get to some things we've wanted that people have asked us for a long time. And we're just, we're still going, a lot in store. So at Desmos Studio, we've got a pretty core set of values. Our main guiding principle is that we want to make math accessible to everyone, and not accessible just in the sense of, from a technological standpoint. Can people with disabilities use it? Yes, that's important. And I'm grateful to be on a team that really does value that. Most people give it lip service. We do not. But there are other barriers. There's financial, graphing calculators, especially talking graphing calculators, even more so, cost hundreds of dollars. We don't think that that's reasonable. Our view is that nobody should have to pay for a math tool. And so we make our tools available to the public to use for free. And we try to keep things as transparent as possible. We want people to be able to use the tools, not have to learn a million things in order to, just do something basic. So access and ease of use are very critical to us, and people like Marielle and our other support associates who just work with our users day in and day out. We have a good pulse of what people need, what may not be working for them, and how we could improve. So with that, I invite any of you watching this today, whether you're here live or not, if you use our tools and you have feedback, we want to hear it because we will actually receive it and act on it if we need to. All right. So the next thing I'm going to do, if you'll pardon me, I'm going to share my screen, which is running JAWS for Windows here, for those who are curious. So you will hear my speech. And we're going to show, or I'm going to keep this active basically throughout the remainder of my presentation here. All right, so Tiffany, I think I'm going to kill your slides here, if that's all right.
All good, it's yours.
Here we go.
Screen. Meeting.
All right, wait for JAWS to. Thank you.
Desmos Beautiful Free Math.
All right.
Desmos.
So.
Participants can now.
Okay, JAWS, thank you. That's quite enough. All right. So where do we go to find anything about Desmos? Well, let's start at the homepage, which is www.desmos.com, desmos.com. And at the top of the page, we have a set of drop-down menus.
Same page link.
I'm just down arrowing here in JAWS.
Visited link graphic Desmos logo. Navigation region. Link collapse menu math tools.
First item we have here is math tools. If I expand that with enter, we can then
Save visited nav link
go
list of AI.
down to
Visited link graphing calculator. Link scientific calculator. Link 4 function calculator. Link test practice. Link matrix calculator. Visited link geometry tool. Link 3D calculator.
basically all of the tools that we have available here. They all have very convenient shortcuts. And you can also find our documentation here. There's also our accessibility page, desmos.com/accessibility, which is linked in the footer at the bottom of the page. But definitely strongly recommend looking at this because it describes all of our accessibility supports in very fine detail. But it also gives some hints on configuring your screen reader or magnifier, depending on your device, to work optimally with Desmos. One thing with Desmos is because we are essentially a web-based application, our technology has the advantage of running on a very wide range of devices. So for example, today I'm coming to you from a Windows laptop running JAWS. But we work just as well on a Mac or a Chromebook or an iPhone or an iPad or an Android mobile phone and tablet. And if anyone here has students using devices like the Braille Sense from HIMS or the Braille Note Touch from Humanware or the any of the Jupyter magnifiers from Humanware or the new Monarch display that Humanware and American Printing House for the Blind are working on. Our technology is integrated into all of these devices to give students the ability to create graphs on board. So our technology runs in lots of places on many devices. So it's important to have your environment kind of set up ahead of time so it works optimally with your students. There's not a lot that you have to do. Technically, there's nothing you have to do, but there are things that you can do to make the experience a little easier. But we're not going to go into any of those details here, but just know we have that information available on the accessibility page. Any questions so far?
None yet.
Okay. Next question, which I know will come up, is where's the Florida specific calculators? Let's show you where those are right now.
Address and search.
So I hit Control L to go to my address bar, and I'm just going to type www.desmos.com/testing.
Blank. Desmos testing. Google Chrome. Steve Desmos.com. Copyright.
And here we are on the testing page.
That-
And if you know specifically which test you want, there are links to get straight to practice calculators that you can run in class. If you're not sure, we do have a search box on the page. I'm going to press E to jump to that.
Try California or star edit. Blank. Try California.
I'm just going to type Florida.
Search results list with 1 items. Florida FSA 1 of 1.
Florida FSA. I know that name is out of date. We will get that addressed. But I pressed return, and
Desmos is on the test.
now we're in a window that says Desmos is on the test.
State test. Link FSA. Grade 7-8. Link scientific calculator. Star. These calculators differ from the ones on our site. You can find more information in the PDF. Link Florida information PDF.
So here are links to the scientific calculator that's currently approved for the Florida state exam for 7th and 8th grade, as well as a link to a PDF that describes any kind of behavioral changes between the version that you'll find on our main homepage and the version that's approved for the test. I want to emphasize that accessibility features between the two will not be different. So anything that I show you today, accessibility-wise, is going to be available for your students. So again, desmos.com/testing, type in Florida, and you'll get this information. In the agenda that was linked and that will be included with this webinar recording, we do have the calculator and the PDF directly linked, so you don't have to go here and look for it. Those will be provided for you. Anything so far?
Nope, don't see anything. Oh, 1 second. If students use the Desmos calculators that are embedded in in testing platforms like Cambium. I think the question is currently being formed. Give it 1 second. Okay, so the question is, if the students use the Desmos calculators that are embedded in testing platforms such as Cambium, are there accessibility differences?
As far as the calculator itself, no. It's possible that Cambium might have some external user interface that's embedding the calculator that might have its own pieces that you need to learn, but that's something that we don't have any knowledge or control over. But the calculator that will be in that test should essentially behave the same in both this testing version that you can access now, as well as the main version that's on the homepage. Anything else?
Not yet.
All right. Well, in that case, let's move on to kind of the main meat of the presentation here. And I'm going to actually load not the scientific calculator, but I'm going to load the graphing calculator because it's, again, one of our more powerful, flexible tools. And any accessibility features in the graphing calculator that you see, especially related to working with expressions, that's all the same across our tools. So I'm going to go back to the address bar with Control L.
Address and search.
And go to desmos.com/calculator.
Desmos graphing calculator. Google Chrome. SteveDesmos.com.
All right, so the features we're basically going to explore today inside the calculator include, in not necessarily this order, but we're going to look at how to work with large print and reverse contrast text. We're going to look at how to audio trace graphs. If that doesn't mean anything to you, don't worry, it will. We're going to look at how to work with Braille, as well as export items to a Braille embosser, if you have access to one. And of course, we're going to look at just the basics of writing equations, getting output. So I'm currently in the Desmos graphing calculator. And let's first start off by just writing a very simple equation that doesn't graph, it's just an equation. So we'll start with everyone's favorite example of 2 plus 2. So I'm literally going to type 2, the plus sign,
Plus.
and the number 2.
2. 2 plus 2 equals 4.
And JAWS reports that 2 plus 2 indeed equals 4. All the speech you heard was generated from the calculator itself. So any tool that you're using, it doesn't have to be JAWS. You'll be able to hear these evaluations happen once they pop up. If I want to review what was evaluated, I can also just tab to the evaluation.
Delete expression 1 button.
So here's the delete button. If I want to do that, I'm just pressing tab one more time.
4.
And here we are with 4 as my evaluation. I will shift tab back to the first
Delete
expression.
Expression 1. 2 plus 2 equals 4. Edit blank.
2 plus 2 equals 4. Okay, I'm going to do Control A and then delete to remove this.
2 plus 2 blank 2.
Next thing I want to do is show maybe a slightly longer evaluation. And we'll type in kind of everyone's favorite sort of mythical number, pi, which we can do with just the letters pi.
P. I. Pi equals 3.14159265359.
And we heard pi equals 3.14159, etc., etc. So again, we had the evaluation spoken once once it had been calculated and we had stopped typing. And we can copy that out from the expression list if we need to, say, paste that into a Word document or an email or anything where we need to, write evaluations down as we're coming up with them. So nothing special a student needs to do to get any of these results spoken for them. All right, I'm going to remove this equation.
Pi.
Again, Control A and then delete. Moving a little more advanced, I want to show how we handle, more complex items like a fraction. So a lot of calculators will say things like 1/2 or 2/3 for 1/2 or 2/3. Or sometimes they may not even speak the slash. You'll just hear 1, 2 or 2, 3, and that's not helpful. We recognize this, and one of the inherent designs in our custom equation editor that we've written is that it's aware of how to pronounce equations and parts of equations verbally. What do I mean by that? Essentially, that 1/2, we know, first of all, that this is a fraction, and second of all, that we can pronounce it better. We don't have to say something like start fraction 1 denominator n fraction, or denominator 2 n fraction. We can just say 1/2 because that's what it is. That's how students say it. That's how most people say it. That's certainly what you're going to more than likely hear in the classroom. So let's just type 1/2.
1 over 2. 1/2 equals 0.5.
And we hear 1/2 equals 0.5. What if I change this
Fragment
to,
blank.
how about 5/6? So I'll just type 5/6.
5 over 6. 5/6 equals 0.8333333333333.
Okay, that was a bad example because we have a repeating decimal, but you heard JAWS say 5/6 equals 0.8333 repeating. And similarly, we do the same once students get into algebra and they start dealing with equations that involve, for example, x and y. You might have the equation for a parabola or a polynomial start with y equals x superscript 2, which we normally say is y equals x squared. Well, we do the same thing.
Fragment right.
If I type y equals,
Y equals
and then I'll
Y
type x,
X.
and then the superscript symbol,
Y equals X.
which is shift and the number 6 on US English keyboards.
Superscript.
And I'm going
Y
to type
equals X.
the number 2.
2. Y equals X squared as graph.
We heard y equals x squared, and we also heard that it has a graph. So to put all that together, we can write something
Y
like
blank
y equals
equal
2 over
oh,
3.
3
And then I'm going to
after
do x squared.
super 2.
And we hear
Y equals 2/3 X squared as graph.
y equals 2/3 x squared has graph instead of y equals start fraction 2 over 3 n fraction x superscript 2. We just hear how you would, how a math teacher or student would say it. So this took quite a bit of work to do over time, but it's work that I'm personally very proud that we did take the time to do. And I hope that this part at least will make kind of going from written math to verbal math through a screen reader fairly transparent. Of course, when we get into more complicated expressions that don't just cancel down to something simple, then we do have to give the longer forms. But for basic stuff, this should work, especially for any students in K through 8, especially. Any questions about the equation editor?
Nothing yet, Steve.
Okay. Then we will move on. If you see anything, feel free to interrupt.
Yeah, of course.
All right.
Y blank.
So that's the equation editor. And again, everything I just showed you as far as how the speech is provided, how evaluations are automatically read aloud, and how we transform math into what we call math speak. That's available in all of the calculators, including the testing calculators for Florida. So the next thing I want to do is demonstrate what we call audio trace. what is audio trace? Audio trace is a mode where a student can explore a graph through sound and the keyboard. So basically what happens is if we graph something on the calculator, a student can turn this mode on and move around that graphed curve, hear what the coordinates are, and also get a sound representation of what's been drawn. So I'm going to start with probably the most simple example of a line, and this is y equals x.
Equals. X. Y equals X as graph. To audio trace, press Alt plus T.
And we heard y equals x. And then instead of an evaluation like equals 4, we heard has graph, and to audio trace, press Alt plus T. If you're using a Mac or any kind of other Apple device like an iPad, and you have access to an external keyboard, you will have heard the same message, except that you would be prompted to press Option T instead of Alt T. But the other behavior will be exactly the same. All right, so let's press Alt T and let's see what happens next.
Graph paper. X-axis visible from -10 to 10. Y-axis visible from -7.16821 to 7.16821. Grid lines are visible. One audio traceable curve. Graph paper. Audio trace on. Use arrow keys to navigate. To hear the graph, press H. To disable audio trace, press Alt plus T. Expression 10 and intercept at X 0, Y 0.
All right, so there was just a lot of stuff spoken there. So let me break it down to kind of the essential pieces of what we just heard. So the first thing that happened was the active cursor, the place where your keyboard is, essentially, moved from the expression list that's on the left to the graph paper on the right. When that happened, JAWS described the graph paper, and we also heard some basic characteristics about it. What we heard was the range of x and y. X was -10 to 10. Y was -7.16821 to +7.16821. We heard that the grid lines are visible because, yes, this is something that you can turn off. So we feel it pertinent to point that out. And finally, you heard information about audio trace itself. We heard what expression we were looking at, which in this case was expression 1, because there is only one expression right now. And we heard a few tips on using audio trace. We heard that to hear the graph, we can press the letter H. And to exit audio trace, we can press Alt T again. So this is a mode it's easy to get out of. You're not going to get stuck. And to demonstrate that, I'll just do Alt T right now.
Expression list region. Expression 1. Y equals X as graph.
And we're now back in the expression list from where we started. So turn audio trace back on, Alt T.
Graph paper.
And we don't need to hear all those announcements again, so I silence JAWS with tapping Control. So the first thing I want to do is give folks just a minute, maybe not quite a minute, but a few seconds. Think about what this graph might sound like. If anyone watching this cannot see what's on the screen, we basically just have a line, a diagonal line going from the bottom left to the top right of the graph paper. Does anyone want to take any guesses as to what this is going to sound like when we play it?
I have a comment in the chat that says low to high. Low pitch to high pitch is another
Right.
one.
All right. Got some sharp people on today. Yes, we will hear a low pitch going up to a high pitch. There's a couple other cues that will occur. I'll explain them after we do that, but let's go ahead and hit H and end the suspense. So what just happened was we heard a line play from left to right. Visually, there was a trace point that kind of swept across the graph, sort of in time with the audio. What does not get translated over Zoom is the fact that this playback was in stereo. So in my headphones, I heard the graph begin playback about maybe midway on the left side of the stereo field. It panned across to the right side and ended at about the same place. And as the position changed in my headphones, the pitch also changed. So those two cues right there give me a left to right, top to bottom view of what this line is doing. There were a couple of other cues that played as well when I did this. I'm going to press H again and see if you notice what they are. Anyone catch them?
Static is one observer.
Very
That's
good.
awesome. I will say, just so you know, Steve, the point isn't doing a great job of moving very smoothly because of Zoom. Change crossing
Yeah.
00 is another one. So just so people who are watching know, like if you're doing this on your own computer, that will move a lot more smoothly. So things like the static and the change crossing 00, I think would be more evident on your own screen. But yeah, we got another one for change crossing 00.
All right. Love the feedback here. And yes, Zoom seems to bog things down quite a bit. So I I don't want this to be a negative takeaway about our calculator's performance. It actually performs quite well. But we work with what we got. So yes, we heard static and we heard the kind of the overall timbre of the note change after we crossed 00. So let's explain what happened. The static was heard whenever X was below, or excuse me, whenever Y was below 0. So when Y was negative, we heard static. Once it became positive, the static went away. When X was below 0, we just heard kind of the plain note by itself. So when it was to the left. Once we passed that line of 00, and we're going up into the air, there was an additional overtone added to that note, kind of made it sound more like a baseball organ. So I'll play this one more time, see if you can catch it. So if we're going from left to right in stereo, why do we have these cues? Well, there's a couple of reasons. One, it helps reinforce the features of the graph. But more importantly, if you don't have access to something in stereo, like Zoom, or you have maybe a device with just one speaker, maybe you're a student that can only hear out of one side. We didn't want the stereo field to be kind of the exclusive way that we communicate information. If we can find multiple modes to do it, we will, and we do. So even without hearing in stereo, if I heard this line and I heard the cues change, I would know what was happening. So I want to make that very clear. You know, you don't have to emphasize one mode over another. Whatever works for your students, hopefully will be sufficient from here. Okay, so that's the line in aggregate. If I want to explore the line itself, I can. Just like your students might be used to working with a word processor like Word or Google Docs, or even just basic Notepad. The right arrow key typically moves you forward a character, left arrow moves you back by a character. Up and down kind of do the same with lines. Well, those same techniques work here. In this case, I'm going to press the right arrow key.
X 0.2, Y 0.2.
We heard a brief blip, and that kind of represented the point on the line that I'm examining, cues and all, position as well. And we also heard JAWS repeat its coordinates. X was 0.2, Y was 0.2. And you would see these same kind of things if you were manually tracing over the graph with a mouse pointer.
X 0.4, Y 0.4.
And I hit right arrow again. Same kind of cues, but now we're at 0.4, 0.4. If I missed any of what JAWS just told me, I can ask Desmos to have it repeated. The letter X will speak the X coordinate.
X 0.4,
Y will do the same for Y.
Y 0.4.
Of course, they're both 0.4, 0.4, because again, this is a line, so Y and X are going to be the same throughout. If for some reason I want to find out, is there anything special, unique, notable about what I'm looking at right now, I can ask Desmos for its type by pressing the letter T.
Not a POI.
In this case, we hear this is not a POI, not a point of interest. I suppose that's up to interpretation, but in this case, a point of interest is something special about a graph. Whether it's an intercept, a root, an extreme, or maybe most importantly, in a lot of cases, an intersection with another line. So we don't really have, well, okay, we do have one feature in this graph. So moving kind of to the analogy of Windows concepts here, just like you use your arrow keys to kind of move through documents, if you want to get to larger parts of a window, you would normally use Tab or Shift Tab. Same applies here. I can hit Tab. It won't take me anywhere, but
No more points of interest. X 0.4, Y 0.4.
we hear no more points of interest, and then my current position is repeated. Shift Tab will take us to the previous point of interest, of which there is one. So we'll press that now.
0 and intercepted X 0, Y 0.
So we hear that this is both a 0 and an intercept at X0, Y0. So now if I hit T to hear the type,
0 and intercept.
we hear 0 and intercept. So let's make this a little more interesting. I'm going to turn audio trace off with Alt T.
Expression list region. Expression 1. Y equals X as graph.
We're back in our expression. Now I'm going to add an expression. I can do this a few ways. I can press enter to make a new line. I can hit the down arrow to add a new expression. We can also add one with a keyboard shortcut that's unique to expressions that doesn't require you to be in the expression list at the time. I'm just going to press enter.
Expression 2 edit blank.
And now we hear we're in expression 2. So now let's do the backwards equation of this line. We're going to do y equals negative x.
Equal. Negative X. Y equals negative X as graph. The audio trace. Press Alt plus T.
And going back to the point about our customizations to the talking equation editor, in other systems, you would hear something like y equals dash x, or maybe y equals minus x. We know the difference between negative x versus minus x. For those of you who care about such distinctions, we do. So I wanted to point that out. All right, so before I turn audio trace on, I suspect everyone already knows what this will sound like, but if you have a guess, go for it.
High to low. Got in the chat. Oh, high to low with static. That one's fun.
The question is, where will the static be? But yes, you are all correct. All right, let's find out. I'm going to do Alt T to go back to audio trace.
Graph paper. X-axis visible from negative 10 to 10. Y-axis visible from...
And our usual graph paper announcement. We're now in the second expression line. And let's hit H. And here we go. All right. We heard high to low, as was predicted. The cues were also heard, but in a slightly different configuration. And there was one additional cue. Did anyone catch it?
Someone said the pop.
You guys are great. Yes, there was a pop. And I'm going to ask another question. Do you know what the pop represents?
This one might be a bit of a guess. Yep, the intersection. Pop one across 0, 0.
Yep. All right. Why are we here today? You all know the answers. I love it. Yes. So this time we heard a line going from high to low. The high part of the line started again with sort of that more plain tone because we were on the left side of X. X was negative. But unlike the first line, which started with static, this one did not. And that's because Y, the vertical part of the line, started above Y equals 0. It was positive. Once we hit 0, 0, we heard the pop to indicate that we had intersected the first expression. We then heard the static, and we heard the overtone of the note, the baseball organ sound. And that was because Y was now below 0, so the static turned on, and X was also positive, so we heard the overtone. So now that I'm on this line, I know that there's a point of intersection here. I can either go explore it manually with my arrow keys, or I can tab around to find it. Well, I don't have to tab because it happens to be where I am now, but we'll hit tab anyway.
No more points of interest. 0. Intercept an intersection with expression 1 at X 0, Y 0.
All right, so we heard the cue of the playback rather of the expression, which included the cues along with the pop. And we heard that this is an intersection with expression 1, as well as the fact that it's a 0 and an intercept as before. If that was a lot to take in at once, again, I can break things down to whatever I need to hear. I can hit X,
X 0,
Y,
Y 0.
T for type,
0. Intercept an intersection with expression 1.
0, intercept, and intersection with expression 1. By the way, if anyone wants to know what the color of this line is, I can hit C.
Blue.
So I know that this line is blue. So I can go to my sighted teacher with absolute confidence and say, I'm on the blue line. And the teacher will go, wow. Well, maybe. But that's something, again, we describe colors to people with screen readers. So this is blue. If I want to find out what the color of the first line is, I can either turn audio trace off and go back to the expression list, go to the first line, find it, or I can do the easier way of navigating expressions while I'm in audio trace, and that's with the Alt up and down arrow keys. Alt up arrow in this case will take me to the first expression.
Expression 1 0 and intercept at X 0, Y 0.
And here we are in our first expression. I hit C.
Red.
All right, so now I know that we have two lines. One's red, the other is blue. Let's make one more equation. I'll leave these on here as they are. Alt T to turn audio trace off.
Expression list region. Expression 1. Y equals X has graph to audio trace.
So again, we're where we were in audio trace. So because we moved to the first expression, that's where we wound up in the expression list. So let's down arrow.
Expression 2.
Here's our second expression. I'm going to down arrow again.
Expression 3 edit blank.
And here's a third blank expression. And I'm going to type Y equals SIN. We're not sinning, we're making a sine graph of X. Again, this is all for demonstration purposes. Don't worry about what this means if you're not sure.
Equals SIN X. Y equals sine X has graph to audio trace. Press Alt plus T.
All right, so even though I typed Y equals SIN X, the calculator knew that that meant Y equals sine of X, and you heard JAWS say Y equals sine X. It didn't say Y equals sin X. And we have a graph, so Alt T.
Graph paper.
All right, this line's a little different than the other two. Do we have a guess as to how this will sound?
I have up and down.
Up and down indeed. All right, let's hit H and find out. All right, so the first two graphs, again, this may not come across through Zoom because I noticed this in stereo, but the first two graphs were a bit narrower as far as what was played and where they were in the stereo field. This graph was wider. Much more was being drawn, going basically from hard left to hard right. And that's reflected, with what I hear. I can be confident that's what's being shown on the screen. A sine wave does go up and down, and so that's what we heard. The line kind of go up and down and up and down, and eventually, when it crossed 0, 0, we heard that pop because it intersected the other two expressions. There are several more points of interest on this particular graph. So let's tab through and find some of them. I'm going to hit tab now.
Extremum at x, start fraction, pi over 2, end fraction, y1.
And we heard we're at an extremum. Not sure which is the correct pronunciation, but either way, this is an extreme part of that line. And so we identify it. And I missed what x was. That was kind of the important piece. So let's hit the letter x.
X, start fraction, pi over 2, end fraction.
All right, so we're at pi over 2. If I hit the letter y,
y1.
we hear we're at pi over 2, y1. Tab again.
0 at x, pi, y0.
And we have a 0 at x of pi, y0. Tab again.
Extremum at x, start fraction, 3 pi over 2, end fraction, y negative 1.
3 pi over 2 and negative 1.
0 at x, 2 pi, y0.
2 pi and 0.
Extremum at x, start fraction, 5 pi over 2, end fraction, y1.
And 5 pi over 2 and 1, etc. And shift tab would take us in the opposite directions. All right, we're going to make one more equation.
Expression,
Hit Alt-T to turn audio trace off. Down arrow.
expression 4 edit, blank.
This time, we're going to make a circle. And I'm just going to type x squared plus y squared equals 9. So x superscript 2
Superscript 2
plus
x squared plus
y superscript 2
2
equals
baseline
9.
9. X squared plus y squared equals 9 as graph to audio trace. Press Alt plus T.
All right. Final guess. What's this going to sound like?
I don't see any guesses quite yet.
It's kind of a tricky one. And if you don't know, that's okay.
Oh, I got it. When it intersects another equation, does it pop mind blown emoji?
Yes.
Not sure on that one. So another. Yeah, it's definitely hard to see. Hard to see when they're crossing right now. But that pop you're hearing at 0, 0 is at 0, 0 or has been at 0, 0 every time.
Yes.
So we're gonna get some pops for sure.
All right. Let's see what happens. So again, this is a circle. And
Graph paper.
Alt-T to turn audio trace on, and let's hit H and see what happens. I'm going to slow this down a little bit. We have keyboard shortcuts, by the way, to adjust playback speed of audio trace. We can either go very slow to really fast. So I'm actually going to choose the second slowest speed here with Alt and the number 2.
Graph playback speed 1/2x.
So we're at 1/2 speed. Let's hit H again. All right, that might have been a lot. So let me explain what just happened. This is an equation that has two solutions. The other equations we showed before only have one. In Desmos terms, we call these branches. And what this basically means is the top half of the circle is one solution, the part that goes down, and then back up. The second is the part that goes up and then down. The part where those two sort of mathematically meet is what makes this a circle. At the moment, Desmos plays each branch in order. So you heard the bottom part first, and then the top part. So let me play this again. There's the bottom, here's the top. So all that to say that we can graph, we can provide audio cues for graphs, but just keep in mind, audio is not the be all and end all of providing graph supports to your blind students. There are some limits as to, what's reasonable for a student to try to interpret through sound alone. And from my own experience, it's, if you have access to a tactile graph, that's going to be immensely helpful. In some cases, that might be the only way to really understand a graph, that has multiple solutions like this. Or when you get into more complex diagrams, it's easier to just feel it than try to get a rough approximation of it through sound. So just so you are aware, we know that audio trace it's great. It provides a lot of power and flexibility, but it's not the only tool that you have at your disposal. So with that, I want to first open up to any questions about audio trace in general or this last example before we pivot over to talking about Braille.
I've got a question before we move. When the audio is playing, does it go in the circle all the way around, or does it do the bottom left to right and then do the top left to right?
It did the bottom left to right and then the top left to right. By the way, if you want to hear any of those solutions by themselves, you can. So for example, if I just want to hear the bottom half, I can hit the number 1 because it's branch number 1. And that's all we heard. If I want to hear the second, I can press the number 2. And hearing those in isolation might make it easier because the student can listen to those pieces, at their own pace. They're not just going bam, bam, one straight into the next. Does that help?
I have another question, a follow-up question to that. So the person said, yes, thanks. And then another person asked, listening to those parts in isolation, you have to be in the trace mode?
Yes.
Question mark.
Yes, that's correct.
And another thank you.
All right. Any others?
Nothing yet, but we appreciate the questions, so keep them coming.
Yeah. And if you still have audio trace questions, want to just pop them in the chat, we can stop and answer them at any time. So, all right, let's move on to talking about Braille. First, I'm going to turn audio trace off with Alt-T.
Expression list region.
And here we are back in our expression list. So refreshable Braille support is very important, something I personally hold very near and dear. Braille literacy is something I'm a very strong proponent for. And a solution that I've often heard throughout disability circles is, students can work with a talking computer. They don't need to learn how to read Braille. They don't need to learn how to write Braille. I do not agree with that stance. And especially when it comes to things like mathematics, there's a special print, almost a language, a notation for writing math symbols. You can see examples of that on the screen right now. We turn that into speech. Okay, that's great for spoken work, but if you are using Braille, there are also Braille math codes that exist for the same purpose, to express mathematical ideas concisely and completely. For example, it's much more concise to see y equals x written in Braille math notation than it is to see y, the word equals spelled out, x. Fractions are worse. You could see y equals the words start fraction, 1 over 2, end fraction. That takes up a lot of space, whereas in, say, Nemeth Braille, you would have y equals open fraction sign, 1/2, close fraction sign, and that's it. It takes up a lot less space. It's easier to read. And if you're working with a refreshable Braille display that has, 14, 20, 32, 40, maybe for really lucky 80 cells, that that's a lot of scrolling. That's going to slow people down. So with that in mind, we do have the ability to live translate to and from the Nemeth and Unified English Braille codes embedded in the Desmos graphing calculator. I say the Desmos graphing calculator, it's also in the 4-function and scientific calculators. And I believe, don't quote me on this, I believe the support to enable those features also exists on the testing calculator. If not, and your student needs Braille access, definitely recommend contacting the test vendor just to be sure that those supports are ready. But the calculator here can do that. So let me show you how that's done. There's 2 ways. The more point and click friendly way is to open the graph settings menu. For the visual folk among you, this is the wrench icon on the right-hand side of the screen. From a screen reader point of view, we call this graph settings. And we also have a keyboard shortcut. We have lots of keyboard shortcuts, by the way, to go through pretty much any part of the system. And I'm going to use one of these shortcuts right now, which is Control Alt and the letter G to get to graph settings.
Graph settings controls region. Graph settings region. Display size group. Display size. Default radio button checked. 1 of 2.
All right. So, well, since we're in graph settings, we'll detour real quick and show you our large print and reverse contrast modes. So the first option we actually have is the text size. We're in default mode now. If I want to make the text a bit larger, we can do that. I'm going to press the down arrow.
Display size. Large radio button checked. 2 of 2.
And now the font has increased to make text hopefully easier to see for those who need it. Of course, if that's not sufficient, you can also use the built-in browser zoom. We'll go back to normal mode here.
Display size.
Excuse me, default mode, not normal mode. With the up arrow. And then I will tab once to
Reverse contrast checkbox not checked.
our reverse contrast checkbox and press the space bar to check it.
Checked.
And now the graph especially has been inverted to make this easier to see for those who prefer light on dark. So again, this is available right here in the graphing calculator. The scientific and 4-function calculators do have the option to change your text size, but they do not have reverse contrast mode, just so you're aware. Any questions about this part before we go over to Braille?
No questions yet. They said repeat that, please.
Sure. Okay, so all of our calculators have the ability to, for you to change the size of the text. But reverse contrast mode, for now, is available only in the graphing calculator.
And geometry in 3D.
And geometry in 3D.
just not the, so the for function and the scientific, which I believe is on the tests, and I know we'll talk more about that at the end,
Yes.
does not have a reverse contrast mode. Awesome. I think we're good to keep going.
Okay. We'll go back to non-reverse mode.
Not checked.
All right, so tab again.
Braille mode checkbox not checked.
Braille mode is currently not checked. You also notice the accessibility settings are the first things you come to in graph settings. You don't have to tab through a million times to get to them. So Braille mode, when I turn this on with space, you're going to see a few changes in the calculator itself. So let's do that now.
Checked.
All right, so we have Braille mode on. And if I tab, there's a few additional options available now.
Braille mode group. Nemeth radio button checked 1 of 2.
We have our mode, which Braille translation language are we going to use? We default to Nemeth Braille. If we want Unified English Braille, we can down arrow
UEB radio button checked 2 of 2.
to UEB. I don't. I grew up with Nemeth. I'm more comfortable with that myself. So
Nemeth radio button checked 1 of
we're
2.
going to go back to Nemeth with up arrow. Tab again.
6 key Braille input checkbox not checked.
All right, we have a box here that's called 6-key Braille input. If your student is accessing the calculator with something like JAWS, NVDA, VoiceOver, TalkBack, Chromebox, whatever, with a Braille display connected, and that Braille display has a keyboard, a Perkins style 6 or 8 dot keyboard, you do not need to use the 6 key mode checkbox. This option is here in case you don't have access to a Braille typing keyboard. In which case, when it's on, you can use the home row of your computer keyboard, the S, D, F, and J, K, L keys as your Braille dots. So most students probably won't need this, but if you are working as a TVI and maybe you just need to write down some Braille math equations, you can turn this on and write those dot patterns, as if you had a Braille keyboard in front of you. Tab again.
Learn more link.
And we have our Learn More option here to learn more specifically about Braille.
View examples link.
As well as links to show how to type some basic equations if you've never worked with Braille before.
Grid checkbox checked.
And here we are. Here's our option to show or hide the grid lines. We don't need any of these other things right now. So I'm going to press Escape. That will close this menu as well as any other menu inside Desmos.
Graph settings button menu.
And now we're back on our graph settings button, which is that wrench icon. So Control-G took us to graph settings. Control-Alt-E will take us back to the expression list. So I'm going to press that now.
Expression list region, ec1 edit, y.kx.
All right. We used to have a thing here that said y equals x. Now we heard ec1 y.kx. And why is that? Well, this is a sort of disadvantage to working in a web-based environment. We don't have direct access to a screen reader to tell it what you're looking at now should be interpreted as Braille. The best we can do is provide the Braille characters to be shown on the display, but JAWS doesn't know any better, and so it's trying to read those characters out as text. So you kind of have to pick and choose. Do you want to work in Braille mode or speech mode? We can't currently do verbal math while inputting and outputting Braille. I'd love it if we can, but today that's just not how it works. So in Braille mode, pretty much ignore what JAWS says. And that's what we're going to do here. But on my display, I would be seeing y equals x in Nemeth code. The y and then dots 4, 6, then 3, 6 is the Nemeth equal sign, of course, surrounded by spaces, and then the letter X. And also on the display, we shortened the label from expression 1 to EQ1, equation 1. So again, trying to save space where we can. If I down arrow,
X2 edit y.kx.
And then we hear, again, ignore it, but it would be y equals minus x with appropriate Braille signage.
X3 edit y.k sin x.
And we have y equals sine of x on this line. And finally,
X4 edit x2 plus y2.k number 9.
and we have x squared plus y squared equals 9, again shown with proper Nemeth notation. Now notice this all turned into Braille automatically for me. I didn't have to write a single dot. And this is true of any graph that you can open in Desmos. Whether a blind student created it, a sighted teacher created it, a sighted student made it, doesn't matter. This Braille translation happens as it's requested on the user's device. We never have to actually store any Braille on the server. Conversely, if I add a new equation now by pressing the down arrow,
X5 edit blank.
I'm just going to type the Nemeth symbols for the square root of 2. So the open radical sign, the number 2, and the close radical sign. You'll notice we didn't hear any extra speech because, again, we're in Braille mode, so we don't need to talk. But I know that something's been evaluated. And on my display, I can either scroll through the calculator to find out what that answer is, or just as I showed at the beginning of our demonstration, I can tab to the evaluation itself.
Delete expression 5 but read only edit.k number 1.41421335.
And visually, or excuse me, on my display, I also see the Nemeth equal sign. So again, we're now responding in Braille, not just translating what's been input. But we see the number 1.41, etc., etc. That's the square root of 2. Let's shift tab back to the expression
X5
list.
edit 2 right brace.
And okay, so now I'm in Braille mode. That's great. Maybe I'm a student working with a sighted teacher or another classmate who's fully sighted, and we're sharing a computer. Might be kind of a hassle to jump through the graph settings menu, tabbing to Braille, or changing the mode, manually with the arrow keys. There's got to be a quicker way, right? The answer to that is yes. So we have keyboard shortcuts for changing your Braille modes as well. And again, you don't have to remember everything here. These are all documented. But we are in Nemeth. The keyboard shortcut to get that mode was Alt-N, by the way. If I want to go to Unified English Braille, maybe I want to see what does the square root of 2 look like in UEB. Maybe I'm just curious or I have to learn it. I can press Alt and the letter U.
Braille mode UEB, X number E.
And now we see the dot patterns for the equivalent of the square root of 2. And all of my other equations above this line have likewise been transformed. So going back to the example of the student working with a sighted peer. To get back to print mode or typeset mode, we can press Alt-Q.
Expression 5, start root 2, end root equals 1.414213562237 edit blank. Braille mode off.
We heard the typeset, the print version of the equation, because we are now seeing the print form of the square root of 2 that I originally typed in Braille. We heard JAWS say the evaluation, so I could hand this machine off now to a sighted student. They could do whatever, hand it back to me, and I could go back to Nemeth.
Expression list.
And we could just keep working together collaboratively on whatever it is.
I got another question in the chat.
Yes.
And so the question is, so the Braille translation is coming from Desmos and not from JAWS?
That is correct. So to that point, I want to emphasize on our accessibility page that I mentioned originally, we do have some Braille setup instructions, and these are not optional. You have to do these. What it basically boils down to is you have to turn off the screen reader's Braille translator for both what's being typed and what's being displayed, both input and output. And the reason for this is because screen readers use what are called literary translators. In every other circumstance, those are great. But what happens is, literary being text. So contracted Braille versus uncontracted Braille, you have the contractions for common signs like ER, AR, ING, that kind of thing. That's great for making reading more efficient. But that all kind of breaks down when working with scientific or technical codes, because those are not literary. You can intermix literary and technical codes technically, like in a document, like textbooks, but by themselves, they are separate. And Desmos, in order to understand Braille, we need to get access to the dot patterns themselves as the user's typing them. And we need to also confidently be able to send dot patterns back to the user. And unfortunately, there's no one Braille translation table that we can depend on to try to work around. So right now, we essentially say we have to turn Braille off, and that's just how it is, or not Braille off, but the translation off. So once that's off, yes, Desmos handles all Braille translation on both sides. Does that answer the question?
Yeah, she said, got it. Thank you so much. And I
Sure.
want to give a time warning. It's 2:54 Eastern.
Sure. All right. One other thing I just want to show real fast is I mentioned tactile graphs, and they're useful to create. Let me just show you very fast where you would do that. We have a share option. I'm going to do Control-Alt-S, another shortcut to get to it.
Link to this graph edit.
And we're going to tab over to Export Image.
Print link. Export image link. Export
Activate this. And in the
off.
file drop-down type, we're going to expand with down arrow.
Braille UEB link.
And we already had a Braille mode selected because we were in Braille.
Braille Nemeth link.
So I'll press
File
Enter to select Nemeth.
Size button.
Tab to size, down arrow.
VP Max 11 point.
Here's our list of supported embossers and paper sizes. We'll just choose one of these.
Size button.
And from here, you can download a PNG, get the graph out of Desmos, and send it off to an embosser. So I know we're short on time, so I will go ahead and stop sharing my screen and turn it back over to Tiffany.
Thank you. I've learned so much. I think I have more questions. I almost would love to just invite you back, but I'm sure that we can email you. Steve, would you mind giving us, or for me to share your email information?
Yeah. So we have a general accessibility account. It's accessibility@desmos.com. That will reach me. I'm usually the one to respond to those anyway. But if anyone wants to reach me directly and bypass that, it's just steve@desmos.com.
Okay. I did see one other question. Let's see in the chat. Does the 4-function calculator have a square root function and a change sign key?
You want to take that, Mario?
Yeah, so the 4-function calculator does have a square root. I don't think it has a change sign key. The one thing I will say is this is something that some states decide to change. So sometimes they'll have the square root key turned off or the percentage key added, or both of them turned off. So yes, in general, maybe on FAST specifically. It's probably a great segue to what Tiffany wanted to share.
Yeah. So if I know there are lots of questions, I know like I have, you talked about contrast, and I'm thinking like, could we still be pairing like Zoom text with some of these other calculators that don't have contrast? I have just some other questions stirring that I know. What I want these teachers to understand is how can they use these calculators? How can we apply what you've shown us, Steve, with our Florida statewide assessments and our current testing environment? Because we don't currently have access to JAWS currently, although it's something that we're working on in our secure browser. But let's first look at what which of our tests and grade levels have calculators approved for them. And so this is calculator guidance for Florida statewide assessments in grades 3 to 5. There are no calculators for math and science or on statewide assessments. In grade 6, students are allowed on mathematics to use an approved 4-function calculator. 7 and 8, mathematics, an approved scientific calculator. Grade 8 science, an approved 4-function calculator. End of course exams, algebra 1 and geometry, an approved scientific calculator. Biology 1, an approved 4-function calculator. And so these are addressing the Florida Assessment of Student Thinking the FAST tests, benchmarks for excellent student thinking best, end of course exams, and science tests. And let's go on just one more slide and really think about what this means, because we have now this really neat range of accessible calculators. And so how can we expand the calculator options now for our students? Right now, we do not have access to JAWS in a secure testing platform right now, but stay tuned, because something might be coming, Florida. And so that will make a whole other range of options available to us. But for now, you can use approved handheld calculators, and we do have in our FIMC loan library the Sci Plus 2300 available. Another option now is, Steve, I'm not sure if you mentioned that there are apps for the scientific calculator and maybe some of the other calculators that are in test mode, that have a test mode. So if your students needed an accessible calculator, they could use the scientific calculator in test mode, and that would be an approved calculator for one of the tests in the previous slide where a scientific calculator is allowable. The online calculators, any of the online calculators, whether it's 4-function, scientific, graphing, could be usable, and if they are the accessible calculator for your student, with a test security plan on file in the district. So while we know there is a, I'm sorry, Steve, forgive me, which is the one that is already in test mode online? There's a testing calculator. Is that the scientific?
Yes.
Yes, the scientific.
It's all 3, I believe. So they'll have
all
access.
3. Yeah.
So there's a
Florida
4-function one as well.
For Florida, with Florida specific?
For Florida, we have scientific, and I am hoping we can get 4-function, but I'm not sure.
Okay.
But if we do, we can get back to you.
Yeah.
Yep.
And so just thinking about the graphing calculator that is accessible, the 4-function that is accessible, but maybe not in Florida specific test mode online, all you would need to do is submit a test security plan on file with your district, basically saying that your student wouldn't use any of the functions that are not allowable. And then of course you can always still use any, reader support with any other approved calculator if that is what is least restrictive for your student. And if you have other questions about what calculators are allowable, I would refer you to a really excellent webinar that we had earlier this year, new to statewide assessments, with Kathy Krempleski and Karen Reno. They gave a wealth of knowledge about just assessments in general, allowable accommodations, and all types of things. So I would refer you to that. And to be respectful of your time, I will go ahead and offer you a closing code of TOOL. So the closing code is TOOL. And if you would, we appreciate feedback. If you would go ahead, and these links, if you don't want to scan them now, are on our website under both upcoming events and past events. But we appreciate your feedback. If you'd like to fill out our evaluation form, the in-service credit form is for you to go ahead and fill out. You will receive a certificate via email, which you can provide to both your district for approval. We have Steve and Marielle's information in the chat. I'm just going to go ahead and flash ours as well. If you have questions, you can reach out to me. If I can't answer it, which in relation to assessment, I will always reach out to experts, either with FIMC or with the Bureau of Assessment, and with the state. I know we can find the answer together. But thank you so much, Steve and Marielle. I know that this just, you know, in any field of accessibility, more access, especially a free accessible tool, is just so valuable to us and to our students. And so I thank you for coming and presenting today. If there's no other questions, I'll go ahead and stop our recording.